I am going to show you the exact reason most engineers fail their first system design interview. It's not that they don't know enough technology, it's that they know too much. They hear design a chat app and immediately start drawing Kafka, Redis, microservices, shared databases, everything they have ever read on Twitter. The whiteboard fills up. They feel productive. And the interviewer is sitting there thinking, this person has no idea what they are doing. Why? Because the entire job of system designer is the opposite, not to add components, to resist them. In the next 10 minutes, I will teach you the one mindset shift that separates someone who memorizes architecture diagram from someone who actually designs systems. It's the foundation of everything in this course. Let's get into it. The system design mindset can be stated in one line. There is no single right answer. Every decision is a trade off, and every trade off comes from a constraint. Read that again. It's the whole job. When you are writing code, there's usually a correct answer. Sort an array. Quick sort works. Reverse a string. Two pointers. The world is binary. Your code either runs or it doesn't. System design is not like that. Ask three senior engineers to design a URL shortener and you will get three different diagrams. None of them are wrong. Each one is optimized for a different constraint. One for speed, one for cost, one for reliability. This is uncomfortable. Beginners hate it. They want to know the right way to design Instagram. There isn't one. There's the right way for a specific set of constraints. Once you accept that, everything in this course becomes easier. You stop memorizing architecture. You start asking, what is this system trying to optimize for? And what it is willing to give up to get it. Stick this in your brain forever. System design is not about knowing more tools. It's about knowing which tool to not use and why. Here's the analogy that will stay with you forever. Imagine you walk into a car dealership and you say, I want a car that's the fastest in the world, the most reliable in the world, and the cheapest in the world. The dealer is going to laugh at you. That car does not exist and it can't exist because fast, cheap, and reliable, you can have any two, never all three. Pick fast and reliable like a high-end German sport car, it's going to cost you. Pick cheap and reliable like a Toyota Corolla, great car, but it's not winning any race. Pick fast and cheap like a tuned up old Honda Civic, sure, until something breaks every other month. Every car on the road sits somewhere on this triangle, and every car is the correct car for someone's constraint. A delivery driver picks the Corolla. A race car driver picks the sport car. They are not arguing about which car is better. They are optimizing for different things. System design is the exact same game. Your database can be fast, it can be cheap, it can be reliable. Pick two. Try to pick all three and you are not designing a system. You are writing a wish list. Once you internalize this, you stop saying use Cassandra because it's scale and start saying use Cassandra if your constraints are write heavy throughput and you can tolerate eventual consistency because the trade-off is no join and harder schema evolution. The last sentence, that is the system design mindset. There are three reasons this mindset more than any specific tool you will ever learn in this course. Reason 1, interviews. The number one thing senior interviewer are testing is not your knowledge of Kafka. It's whether you can say the word. It depends. And here's how I would decide. If you can do that fluently, you pass. If you can't, no amount of memorized architectures will save you. Reason 2 is real engineering. Every architecture decision you make at your job costs your company real money and real engineering time. The ability to say, we don't need that yet, is the most valuable skill a senior engineer has. Junior engineers add complexity to look smart. Senior engineers remove it to ship faster. Reason 3 is you stop getting stuck. Beginners freeze when there's no clear answer. They want a textbook to tell them what's right. Once you accept that everything is a trade-off, you stop freezing. You start asking better questions. The fog lifts. Here's where we are going. Every system you design lives somewhere inside this triangle. The three corners are the goals that pull against each other: fast, cheap, reliable. At the top corner, fast, low latency, high throughput. Your system responds in milliseconds even under heavy load. At the bottom left, cheap, low infrastructure cost. You are not running 100 servers when 10 will do. At the bottom right, reliable, high availability, no data loss. The system stays up when machine fails. Pulling any corner stretches the other two. Want fast and reliable? You are spending real money. Want cheap and reliable? It's going to be slow. Want fast and cheap? Something is going to break. There is no design that sits perfectly in the middle. Every system you build is deliberately unbalanced towards two of these corners at the cost of the third. The question isn't whether to make this trade-off. The question is whether you made it on purpose. Now here is how this changes the way you approach a problem. The wrong way on the left is what almost every beginner does. You hear the question, design a chat app, and you immediately reach for the impressive tool Kafka, Redis, Microservices. You draw a fancy diagram, then you try to justify it post hoc. Because scale, you end up with something over-engineered, fragile, and impossible to defend in an interview. The right way on the right is what senior engineers actually do. Step 1. Clarify the question. How many users? Is this read heavy or write heavy system? Do messages needs to be delivered in order? Step 2. Estimates the number. Queries per second. Storage per year. Bandwidth. Step 3. Identify the constraint. What must be true? What is negotiable? Step 4. And only step 4, derive the simplest design that meet those numbers. This is constraint first thinking. You don't pick the solution and then justify it. You pick the constraint and the solution emerges from them. Often the right answer is shockingly boring. A single Postgres database, one web server, no queue, no cache. The boring answer is usually correct. I want to be honest with you about something most courses won't tell you. The good news, once you start thinking this way, system design stops feeling like memorizing a textbook. Every diagram becomes a conversation. You can defend any decision because you know what constraint it came from. Interviewer love this, teammates love this. The bad news is this mindset is slower. When you are new, it feels frustrating. You can't just say use Redis and move on. You have to explain why Redis and what you are trading away to use this. Junior engineer around you will look more confident because they are not pausing to think. Don't be fool, they are guessing, you are designing. That's not insecurity, that's discipline. The senior engineers above you are doing exactly what you are doing. They just do it faster because they have made the same trade-off 1,000 times before. Even from this one video, you can confidently answer 4 of the most common system design interview questions. Question 1. What's the right way to design X? The answer is there isn't one. The right design depends on constraint. Ask the interviewer about scale, read-write ratio, latency target, and budget before drawing anything. Question 2 is, why did you pick this database? Don't say because it's scale. Say because the constants are X, Y, and Z and this database optimizes for those at the cost of A and B, which we are willing to give up here. That sentence shape passes the interview. Question 3 is, should we use microservices? The answer is almost always not it. Microservices solve organizational problems, not technical ones. If you have one team and 10,000 users a monolith is correct. Say that out loud and watch your interviewer nod. Question 4. How would you reduce cost? Pick a corner of triangle to give up. Are you willing to be slower? Cheaper hardware? Willing to be less available? Drop a replica. There is no free cost reduction. There is always a trade-off, and the right answer is to name it explicitly. That last one alone separates senior candidate from the junior ones, trust me. Before you go, take 30 seconds to lock this in your mind. Takeaway 1. There is no single right answer in system design. Every design is the right design for a specific set of constraints. Stop hunting for the way to build Instagram. Takeaway 2 is fast, cheap, reliable. Pick 2. Every system you design sits inside this triangle, deliberately unbalanced towards two corners. Knowing which two and why is the entire job. Takeaway 3. Constraint come first, solution come last. Senior engineers clarify, estimate and identify constraint before drawing a single box. The boring answer is usually correct. In the next video, we will get into the 4 pillars every system is judged on: scalability, reliability, availability and maintainability. These are the words you will use to describe the constraint we just talked about, and they show up in every system design discussion you will ever have. If this helped you, hit subscribe so you don't miss the next one. The full playlist is the link below. See you in the next video.